Hello guys, welcome to our Smart Interviews YouTube channel. This is 𝗟𝗍𝗃. Today we'll be discussing problems from Starters 162. Let's get started. So the question is assignment score. Chef has a total of n plus 1 assignments. He knows his score on the first 10 of them and he is now working on his last assignment. His score in the first n assignments are A1 to AN. Each of them are graded out of 100 and his total marks is just sum of all his n plus 1 assignments. Okay, chef is now worried about he might fail in his course. He will fail if he scores less than 50% of the total marks. Can you help chef find what is the minimum score he needs to get to not fail? It may be impossible for chef to pass, so in that case we have to output -1. Okay, so given the input format, we are given t number of test cases, and in each test case we are given n in the first line and the integers a1 to an in the second line. Okay, so we have to output the minimum marks in the n plus 1th assignment so that he'll pass. If it is not possible, we can simply print -1. So if you try to understand the test cases, here we have 4 test cases. So this is the first test case. Now given the value of n is equals to 1, so there are total of n plus 1 assignments, so we can say n plus 1 means there are a total of 2 assignments. Now each assignment is graded out of 100, so the total marks is nothing but 2 into 100, which is 200. So the total marks over all the assignments is 200. Now it is known that in one of the assignment he has got 67 marks, so it is given in the input. Now it is also given that chef needs at least 50% of the overall score to pass in the course. Now the total score is 200 and 50% of that is nothing but 100. Okay, so 50% of that is nothing but 100. Now chef needs 100 marks to pass in the course. Now out of these 100 he already got 67, right? He already got 67. Now what is the remaining? 100 minus 67 is nothing but 33. So he should be getting 33 marks in the second assignment to pass the course. And this is the minimum marks. Even if he gets more than that, he will pass in the course. But let us see if he is getting less than 33, he will fail in the course. Okay. So that is why the answer is 33, which is the minimum score required to get in the second assignment. So let us try another test case. Test case number 2. So given the value of n is 2, n plus 1 is nothing but 3. So there are 3 assignments. Total is 3 into 100 because each assignment is given 100 marks. So 300 is the total for all 3 assignments. Now out of 300, if he wants to pass in the course, he should be getting at least 50% of it, which is 150 marks. So he should be getting at least 150 marks over all the assignments. Now we know that the score for the first 2 assignments is 53 and 32. So the total score is 85 here. 85 is the current marks obtained by him. Now what is the minimum marks that you will require in the third assignment to pass? Which is nothing but 150 minus 85, which is 65. Okay, so he'll require at least 65 marks in the third assignment to pass. So similarly, let's look at the third test case. Here 3 assignments are given, n plus 1 is nothing but 4. Total marks is 400. What is the minimum marks he'll require to pass? 200. So he'll require 200 marks. Now it is given that for the first 3 assignments he got 0 marks overall. So he got 0 marks overall. Now in the next assignment, what is the minimum number of marks that he should get? Which is nothing but 200 minus 0, which is 200. Okay, so he'll require at least 200 marks in the next assignment. But can he get 200 marks in the next assignment? He cannot get, right? Because we know that the maximum marks for any assignment is 100. So in this case, it is not possible for him to pass. So we can simply output -1. Okay. Similarly, for the last one, given the value of n is 2, total number of assignments are 3. So the overall score is 300. Minimum marks required to pass is half of it, which is 150. And out of these 150, for the first two assignments, he already got 200 marks. Now, here, if you observe, what is the minimum marks required for him to pass in the next assignment? So we can simply subtract 150 minus 200, which is -50, right? So do you observe that he already got 200 marks and the minimum pass marks is 150. So even in the next assignment, even if he scores 0, he will pass the assignment, he will pass the course, right? So if you are getting the subtraction as a negative number, that means he has already passed in the course, right? Even if he gets 0 marks or 20 marks or whatever, in the next assignment he'll pass in the complete course. Okay. So this is it, guys. First we'll calculate n plus 1, and for the minimum number of marks required is, so the overall score we can say n plus 1 into 100. This is the overall score. Now if we divide this by 2, we'll be getting the minimum marks required to pass in the course. Now if we simply add up the subject scores and subtract from this value whatever we get, if the number is a positive value, we can print that. But if the number is greater than 100, let us say in this case here the number was 200, right? So in this case it is never possible to pass in the course. So if the value is greater than 100, so that is one of the test case. Let us say the value is less than or is equals to 0. Okay, if it is less than or is equals to 0, he will require 0 marks, 0 extra marks, as in the last test case, right? And one more test case is nothing but the general cases, as we have seen here. Okay, so this is the logic, guys. Let's try to code it up. So let us write the code. The first line of input contains the number of test cases. Now for each test case, in the first line we got the value of n. The next line contains the list of integers. So now that we have the list with us, we can now find the sum of the scores across all the assignments. Now we have the sum of scores across all the assignments. Now what is the overall score across all the assignments? We know that there are n plus 1 assignments, and in each assignment we can have a maximum of 100, but we know that the pass marks is 50% overall, so we can say into 50 to get the minimum pass marks. So this is the minimum pass marks. Now there are a few cases here. So let us say if the minimum marks, right, if m minus the sum is greater than 100, right? In this case it is never possible for him to pass in the course, so we can simply print -1, right? What is the other case? Let us say he already have the minimum marks to pass in the course, so even if he scores 0 in the last assignment, he is going to pass in the course. So if the sum is greater than the minimum, we can say greater than or is equals to print 0, and lastly we can simply print the minimum score required, which is minimum minus sum. Okay, let's try to run this. And we got the expected output. Let's try to submit. Yes. So this is the code. So the question is, adjacent sum array. Chef had an array A of length n of positive integers. He calculated an array B of n minus 1 integers, where B of I is equals to A of I plus A of I plus 1. Okay. So let us say we have A as 254. Now B can be calculated as 2 plus 5, which is 7, and 5 plus 4, which is 9. Okay, so this is how we get array B. Now unfortunately Chef has forgotten the array A, and the elements in the sequence B have been shuffled. Given the shuffled sequence B, predict the original array A. If multiple answers exist, all will be accepted. Now it is guaranteed that the input is generated in such a way that the valid array A will exist. Okay, it will always exist. So the input has the test cases, and each test case has n, and then followed by n minus 1 integers of B, which are in a shuffled manner. So let us say here we look at the first test case. There are n integers and we have n minus 1 integers given, which are 9 and 7, right? So here we can say, if we consider this 9 as sum of two numbers, now we have to note that here if the multiple sequences are possible, we can print any one of them because all of them will be accepted. Okay, and also A of I should be greater than 0. So if you consider this 9 as sum of two numbers, let us say 3, and if one of the number is 3, the other number would be 6. So 6 would be the other number. Now for 7, 6 is one of the number, the other number would be 1. So 361 is one of the possibility. But even if you look at this, the output is something like this. Now here they are taken the order such as 7 and 9. One of the number is 2, the other number would be 5. So 7 is the sum of 2 and 5. Now similarly 9 is the sum of 5 and one more number. The one more number is nothing but 4. So this is the given output. Now even if we take 9 7 or 7 9, we got different outputs. Now for 7 9 also we can get multiple outputs. Let us say one of the number is 1, the other number would be 6. So in the output we can say 1 6. Now this 9 is sum of 6 and one another number, which is 3. So we can say this is one of the possible output. Now even this is accepted. Even this is accepted. Now let us say we are considering an array of size n minus 1, which is 2 here in this case. Now we want to generate array A for this. If we take 3 as sum of, let us say, 1 and then 2, okay, so the output will be 1 2. Now the second number is sum of 2 and some another number. That other number is nothing but 2 plus 0, which is 120 is the answer. But can 0 be the value of a of I? It cannot be, right? It cannot be the value. So here we can say one thing: we cannot get the answer for this example. Don't we have any answer for this? We do have an answer. So let us say if we reorder this, and instead of 3 comma 2 we put it as 2 comma 3. So here if you want to write 2 as sum of 1 and 1, 3 can be written as sum of 1 and 2. So this is the possible array for A, right? So when the array is sorted, it will be easier for us to find out the array for A, right? Now it is also given that we can output any possible array, right? So here what I'll always assume that the first integer is always 1. Now we can also choose other possibilities. But let us say here if we have the array A as 1 and 1, right? Now the B array would be something like 2, right? Now if you have one more 1, here we'll be having 2 again. So the minimum possible value of B array will be 2. It cannot be less than that, right? Because A of I is greater than 0 and A of I is at least, it is at least 1 or greater than that. So B of I is at least 2. So according to this, our logic is something like first we have to sort the array and then we'll assume that the first integer is 1 and then we can find out the answer. So let us say we are considering this array. We have the array 4, 4 and 4. So this is the given array. Now this is already sorted. I'll assume that it is sum of 1 and the other number is 3. Okay. So the output is 1, 3. After that, this 4 is sum of 3 and one another number, that is 1. Now here this 4 is sum of 1 and the other number, which is 3. Okay. So this is one of the possible output for this array. Now every time what we are doing, we are having a previous integer which is 1 in this case initially, then we are subtracting this with 4 to get the answer 3. The next time the previous is nothing but 3, we are subtracting with 4 to get the output as 1 and so on. So let us try to convert this logic into code so that you'll have a better understanding. Let us look at the code. Scanner object. The very first line of input contains a number of test cases. Every test case has n. And next line contains the integers of b, the elements of b, and we have n minus 1 such integers. So declare an array. Now we can simply scan them. We have assumed that the very first integer is 1 and our previous will be 1. we can start looping over the array. But before that, we have to sort this array, right? So we'll be sorting it. After sorting, we'll be printing 1 and print the value element minus the previous, and then we can update the previous as I minus previous. For each test case, we can print a new line at last. So first, scanning n, then scanning n minus 1 integers, sorting the array, then printing 1. Then for all other elements, we'll be printing I minus previous, and we have to update the previous. Then print a new line. Let's try to run this. So this is one of the possible outputs and it is working as expected. Let's try to submit this. And this is working. This is the code. So the question is permutation mod k. A permutation p1 to pn is called good if pi mod k is not equals to I mod k for all I goes from 1 to n. Okay, I is the index here. Given the values of n and k, we have to find a good permutation or claim it does not exist. A permutation of length n contains each of the values 1 to n exactly once. Input format, the first line of the input contains t and each test case contains two integers n and k. In the output we have to print p1 to pn, the permutation, and if it does not exist we can simply print -1. Let us try to understand the sample input and output. The first test case contains 4 and 3. Here the value of n is equals to 4, the value of k is equals to 3. Now how can we arrange this? As the given output we can arrange like 3, 4, 1, 2. Now let us understand how we can do this. So the indices are 1, 2, 3 and 4. Here we are considering 1 based indexing. So the value of k is 3, 1 mod 3 is 1, 2 mod 3 is 2, 3 mod 3 is 0, 4 mod 3 is 1. The output is 3, 4, 1, 2, 3, 4, 1, 2. So this is the given output. Now if we want to find out the mod, 3 mod 3 is 0, 4 mod 3 is 1, 1 mod 3 is 1 and 2 mod 3 is 2. So if you observe, the value of I mod k is not equals to pi mod k. So all of these values are different, right? All of these values are different. So this value is not matching with this one, this value is not matching with this one, and so on. So in this way we got one possible answer. So is there any other possible answer? So can I take 2 here and then 3 here? So 2 mod 3 is nothing but 2 and 3 mod 3 is nothing but 0. Okay, even in this case if you observe, the mod values are not same. So this is one answer, and also we could have print 2, 4, 1, 3. Okay, so this is also a possible answer. Now let's look at the next test case. So 1 and 1. So the value of n is 1, value of k is 1. There is one index, 1 mod 1 is 0. Now because there is only one integer, we can only put a 1 here, and 1 mod k is 0. So as you see, these two values are matching, and there is no other integer that you can swap the places, right? So here in this case we cannot write a permutation, so we have to print -1. So what about this? So 1 2 are the indices. K, the value of k is 2, so 1 and 0 is a mod value. If you arrange it like 1 and 2, we will be getting the mod value is 1 and 0, so this shouldn't be there. We can also place it like 2 and 1, so the mod values will be 2 mod 2 is 0, 1 mod 2 is 1, so these two values are different. So this is only one possibility here. So in this way we can print any possible permutation here for this code. So there are few cases when it is not possible to actually print a permutation. Let us say the value of k is equals to 1. The value of k is equals to 1. Now if we have the indices 1, 2, 3, 4, 5 and so on. 1 mod 1 is 0, 2 mod 1 is 0, 3 mod 1 is 0, 0 and 0, right? Now however we arrange this number 1 to n, we'll always get the mod value as 0. So here it is not possible to write the permutation. Okay, so this is one case that we have to keep in mind. Let's look at another case. So let us say the value of k is 2. Okay, now if you have the indices something like 1 2 3 4 5 and so on. So 1 mod 2 is 1, then 2 mod 2 is 0, 1 0 1 0 and so on, right? So we'll be having repetition of 1 and zeros. Here if we take, let us say we are taking only 4 integers, so the mod values are 1 0 1 0. Now we have to arrange these numbers in such a way that we have to get the mod values of 0 1 0 1. Okay, because let us say if we are placing 1 here, these two matches, right? These two values will be matched and will not get the correct permutation, so we can say it should be 0 and 1 only, so that all of these can be different. Now how do we put the values? We can put a 2 here and a 4 here, and then 1 and 3, or else we could have put 4 here, 1 2 and 3. So this is also one possible permutation, and so on. There are few other possible permutations also, but let us say here we have only 3, so we can get 1 0 and 1, right? So if we want to put it like here in this place, we should get some 1 here, so there will be a possible permutation. So if I put 3 here, okay, I am putting 3 here. Now what are left? 1 and 2 are left, so what value should I put here? So because this is 1, I'll put 2 here, so the mod values are different, and what is left? 3. So if you observe, both of these have a mod value of 1, so we can say it is not a possible permutation. So in this way, because the number of zeros and ones are different, we cannot swap them easily, we cannot replace them. So in this case it is not really possible. Similarly, in the case of, let us say we have two more integers, the values are 0 and 1 here. Now here also, because we have two zeros and three ones, we cannot really build a possible permutation. So this is one case that we have to keep in mind, that when the value of k is 2 and the length of n is the value of n is odd, it is not possible to build a permutation. Okay. So these are the cases, guys, where we cannot write a permutation, and in all the other cases we can write a permutation. Okay. So let us say we have the indices something like this and so on. So let us say 6, because we know with it that we can print any possible permutation. We know that the mod value of 1 and mod value of 2 will be different. So in the actual permutation, what I'll do, I'll simply print 2 and then I'll print 1. Similarly, also I understand that the mod value of 3 for any k and 4 mod k will be different. So I'll be printing 4 and then 3. Similarly, I also add these two to get the possible permutation. So this is what I can do for any value of k, because let us say if I am taking the value of k is equals to 3, if I am taking the value of k is equals to 3, 1 mod 3 is 1 and 2 mod 3 is 2, 2 mod 3 is 2, 1 mod 3 is 1. So the values are different here, right? Similarly, 3 mod 3 is 0, 4 mod 3 is 1, here 1 and here 0. So again the values are different, and 5 mod 3 is 2, 6 mod 3 is 0, and here I'll be getting 2 and 0 and 2. So something like this. We can simply swap the adjacent elements to get the possible permutation. I hope this is clear to everyone. So let us try to understand one case. So if you have three numbers 1, 2 and 3, right, when we swap these two, we'll be getting 2, 1, and if you want to swap 3 with some other element, we don't have it. So what we'll be doing here is we'll be swapping 3 of them. So let us say I'm putting a 3 here, then 2 and then 1. Okay, so these two will be having same. We'll be putting a 2, then 3 and then 1. Okay, so this is one possible permutation for 3 of these. Now even when we have more number of elements, 4, 5, let us say 6, 7. Now for the other elements, we can simply swap the adjacent elements, putting 5 and 4, then 7 and 6 and so on. Okay, so this is what we can do when there are odd number of elements. But for even number of elements, as we have seen here, we can simply swap the adjacent elements. So let us look at the code for better understanding. Let us look at the code. So first we'll be having the number of test cases. In each test case we have n and k, right? Now we have to consider the cases where it is not possible to write the permutation, and one of them is, let us say if k is equals to 1, we cannot really write a permutation. Or there is one more case where the number of elements is equals to odd. Where the number of elements is equals to odd and the value of k is equals to 2. In this case we cannot write a permutation, we cannot print a permutation, so we will be printing -1 In all other cases, we can print the permutation. So as we have seen before, when the number of elements is equals to even, we can simply swap the adjacent elements, right? So I'll be writing for loop for int I is equals to 0, I less than n, and I plus plus. Because the permutation is starting from 1, we have to print I plus 1 and I plus 2, right? As we are swapping them, first we'll be printing I plus 2 space I plus 1. We can do I plus is equals to 2, or here I'll do I plus plus. Now when the number of elements are odd in the else condition, we cannot really print a permutation. In these cases, and when let us say n is equals to 1, what will the permutation be? It will simply be 1. In the other cases, that is, the number of elements are greater than 1. Odd elements greater than 1 is nothing but 3, 5, 7, and so on. In that case, we know that first we have to print the elements 2, then the element 3, then the element 1. After printing through 2, 3, and 1, we can simply print the other elements. Starting from 3, I less than n, and I plus plus. So this should print the permutation. Then we'll be printing a new line. So first here, scanning the number of test cases, then scanning n and k. If k is equals to 1, we cannot print the permutation, or let us say the number of elements are odd and the value of k is equals to 2. In that case also, we cannot print the permutation. In the other cases, when the number of elements are even, we can simply swap the adjacent elements and we can print one by one. Or else, let us say if number of elements is 1, so we can simply print that. For the other cases, when the number of elements are 3, 5, and so on, first print 2, 3, and 1, then after that, for the remaining elements, we can simply swap the adjacent ones. Let us try to run this. So 2143 minus 1, 2 and 1. Let's try to submit this. And yes, this is the code. So guys, I hope you like the video. Please share it with your friends and subscribe to our 𝗏𝗃𝗃 YouTube channel. Until the next video, this is 𝗟𝗃𝗃𝗃 signing off.